Okay, class, today we're going to be doing complex numbers in polar form and rectangular form. These should look familiar from first semester. These are complex numbers that are in rectangular form. When they're in rectangular form, you have to think of the real part as just x and the imaginary part as y. Don't worry about the I itself here. We just have to think of that. So to find an absolute value of a complex number, all you have to do is basically find the radius. So if I plot this complex number, 4, 3, the absolute value of this complex number is the length from the center out to that point. So you guys should know how to do that. That's basically your r. So remember, r squared equals x squared plus y squared. So we're using the same formula here, but it also finds you the absolute value of a complex number. So let's do that. So r squared equals 4 squared plus 3 squared. 16 and 9 is 25. So r equals root 25, which is 5. Here we get r squared equals 2 squared plus 5 squared. Got a negative, doesn't matter because of the square. 5 squared is 25, plus 4 is 29. So r, or the absolute value, is square root of 29. Here, there's no real part, so we have 0 squared plus 4 squared. So we get r is 4. So the absolute value would just be 4. So it's the same thing. Absolute value is the same thing as finding r, basically. Okay? Now, here's what's nice about today. This is the same thing you've been doing in the first 2 days, except for it just looks different. Alright? There's a different format for that. So in polar form, it is r times the cosine of theta plus I sine theta. And that should make sense because remember, when you distribute the rn, you get r cosine of theta, which is x, and r sine of theta, which is y, and that's attached to the I, like I said. Now there's a faster way to write this though. We have a shorthand form for cosine theta plus I sine theta, and that's cis theta. Okay? So here's how we're doing this. We're going to use the same formulas. You guys should remember that x squared plus y squared equals r squared, and that theta is equal to the tangent inverse of y over x. However, you have to check the quadrant. You need to do a quad check. Okay. So, let's do this. If I want to find r, r squared equals 3 squared plus root 3 squared. So that would be 9 plus root 3 squared is 3, so 12. So r equals the square root of 12, which also is 2 root 3 if you want to simplify that, and I wrote 2. Alright, by the way, where is this number? We should probably check that before we do it. This number is in quadrant, x is positive, y is negative, we're in quadrant 4. So this is a Q4 angle. So let's find that angle. I have to do tangent inverse of negative root 3 over 3. Now if you're not comfortable doing this in radians yet, use degrees on your calculator. And if you do that, you get that theta is equal to negative 30 degrees. Well, again, that is not correct because I need an angle between 0 and 2 pi, or a positive angle. So instead of negative 30, we're going to say that theta is really 330 degrees. And then the only thing you have to do is convert that to radians, which is divide that by 180 to get the fraction and tack on a pi. Or you know that a 30 degree is a pi over 6 reference, so it's 1 less than a 12/6. So you should get theta equals 11 pi over 6. So the final answer to this is 2 root 3 cis 11 pi over 6. That's the shorthand way. If you didn't want to write the shorthand way, it would be 2 root 3 parentheses cosine 11 pi over 6 plus I sine 11 pi over 6. It's better to write it the second way if you're going to then convert it back to rectangular. Alright, here, this point is negative 3, negative 2, so we're in Q3. I'm going to find my r value. R squared equals 3 squared plus 2 squared. And that's 9 plus 4 is 13, so r is root 13. So we have r. Now we need to find theta between 0 and 360. So again, theta equals tangent inverse of negative 2 over negative 3. And when you do that, I believe I don't have my key in front of me. It's 33.69. Yep, okay. So it's 33.69 degrees. So normally it'd be done except for, is that the correct quadrant? No, this is in Q1. So to get from Q1 to Q3, you have to add 180 to it. Okay, so if we add 180, then you have the 213.69. Okay, excuse me. So my final answer is root 13, cis, 213.69 degrees. And then we're done. Now going the other way is even easier. It was just r cosine theta, r sine theta again, the other two formulas. Remember that. X equals r cosine theta, and y equals r sine theta. Now, you don't even have to really remember that, because all you have to do is really figure out what these values are. So it's 7 pi over 6. That's a 30-degree reference. That's where cosine is root 3 over 2 and sine is 1/2. But this is a Q3 angle. So that means they're both negative. So what this turns into is negative root 3 over 2 plus I times negative 1/2. You distribute the 8. 8 times the cosine of that is negative 4 root 3. 8 times negative 1/2 is minus 4i. And that's how you go back to rectangular. You basically just solve the problem. Here, we don't know what 4 radians is. So you have to be in radian mode in your calculator. And you basically need that x equals 5 cosine of 4 and y equals 5 sine of 4. So find those values. You get negative 3.27 for the x. And then when you do 5 sine of 4, you get negative 3.78. So minus 3.78. Now remember to write it in rectangular form. It's a real number and then an imaginary number. So that would be our final answer. Okay, so that is it. That is converting polar to rectangular using for complex. It's very similar to doing it with points that we did the first day. So we just have a bunch of formulas left for 12.3, and I'll see you next time. Bye.